Okay, in section 1-4 now, today we're talking about domain and range. First thing we come to is just a review of function. Remember, it's a relation where each x value or input has only one y value or output. So we've discussed that in some previous lessons. Now, when you're talking about domain, the domain would be the x values or the inputs of the function. And more specifically, they're the inputs that have an output of a real y value, right? Okay, so really your domain, they're the x values or the inputs. Range, the y values are the outputs of a function. Okay, so hopefully this is not brand new material to you. In your algebra courses, you talk about domain and range. Okay, so if you've got a graph of a function, like for example what we have here, the domain values would be the x values that occur on the graph or on the function. So all of these values from here to here, this would be the domain, whatever these values are. They're not labeled on this graph, but like for example, if this was 2, then 2 would be a domain value, 3 would be a domain value, and so on. So the domain would be from where the graph starts at this point to where the graph ends at this point. Okay, so the x values, that's your domain. All right, now remember, each one of these x values has a matching y value. So the y values would be your range. So from here to here, those would be your range values. So remember, domain, the x values, range, the y values. All right? Here's another example where we're given a table instead of a graph. And so if we wanted to find the range and domain of this particular relation, then for the domain, we need to look at the x values. Well, we have x value of 0, 3, -3, and 2. So that's your domain. Okay, so for the range, we've got a range of 2, 4, and -2. So the reason why there's only 3 values listed here is because 4 is repeated twice. So 3 goes to 4 and 2 goes to 4. All right, so let's stop and think about this. Is this a function? The answer is yes, because each x goes to only one y. 3 goes to 4. Does 3 go to anything else? No. 2 goes to 4. Does 2 go to anything else? No. So this is a function. Remember, you can have repeating values on the y side of the table. You just can't have repeating values on the x side of the table unless they go to the same thing. If I had 3 listed down here again, then it needs to go to 4 again. It can't go to anything else. All right? So keep that in mind. Let's practice some of the problems. All right, so basically, our task here is to be able to take a graph of a function and find the domain and the range for that particular function. All right? So on the first graph that we're looking at here, let's say we are trying to calculate or try to find the domain. And what we'll do is we will express the domain in interval notation. All right, so now, when we're taking a look at this, okay, remember, the graph doesn't stop at the end of the picture here. Remember, the graph itself actually keeps going, right? And so the first thing that we need to do when we're talking about domain is see if we can find the x values. Now, when you're trying to determine what the domain is, you need to ask yourself, well, does the graph have boundaries? In other words, let's start with a lower bound. Okay, so does the graph have a lower bound of x values? So in other words, here's -2, -3. Is that where it stops? Well, that's where the drawing stops, but remember the graph itself keeps going. So is -4 the lowest value, -5, -6? The answer is no, it just continues on forever. And so really, the x values continue on the graph all the way to -infinity. So that's the lower bound of the x values, or the lower bound of your domain. Now, how high does it go on the x-axis? So does it stop at 3? No. 4, 10, 20, 100? Same idea. This graph continues on to infinity. And so that is your domain, okay? In set notation, or excuse me, in interval notation, it would look like this from negative infinity to infinity. So that's just interval notation's way of writing all real numbers. Okay? The domain is all real numbers. Okay? Range. Okay, so now for the range, we're taking a look at the y values that are on the graph. So again, you want to start with the lower bound. All right, so once again, this graph continues on, so -4, -6, -20, -100. Okay, there is no lower bound here, so again, we'll start with negative infinity as my lower bound. And notice with infinity, you always use the parentheses because it can never reach infinity. All right, so it just approaches infinity. It'll never get there. Now, on the other side, we need to ask ourselves, okay, is there an upper bound for the y-axis? Indeed, there is, because here's 0. It hits 1. How do I know it hits it? Solid graph right here. Now, 2, it does not hit. Okay, so there is no input that would yield 2 as an output, so it doesn't get there. 1 is actually my upper boundary, and so the range is from negative infinity to 1, and of course it includes 1, so to finish my interval notation, I'm going to use a closed bracket. Okay, so there's your domain and your range for this particular graph. All right, so several more now we need to take a look at. Here's the next one. Okay, let's see if we can determine the domain of this thing. All right, so when we're talking about the domain, again, we're talking about the x values. We want to see if there's a lower bound. Okay, there is a lower bound this time at this point. And so if this is -2, -3, then my lower bound here is -4. Now, probably need to erase this parentheses because, take a look, we have a solid point here, which means that -4 is included for this particular domain, and so I need to make sure that I have a bracket here. So -4 is the lower bound for the x-axis. Now, let's find the upper bound. How high does the graph go? Now, it goes up to, but not including 4. So that's my upper bound. So I'm going to write 4 as the upper bound for the domain, and then since it does not include 4, then I'm going to put a closed parentheses. How do I know? Because of the open circle. It does not include the value. Everything up to 4 is included, but not 4 itself. So that would be the correct domain for that particular graph. Let's look at the range. All right, so if I'm looking at the range here, okay, I'm doing the same thing, trying to find the boundaries, but I'm looking at y values this time. Start with the lower bound. Is there a lower bound for the y values on the graph? Yes, the lowest it goes is right here to 0. Now remember, you're looking at the the y values for range, not the x. Okay, so if you want to determine if a value is on the graph, then go to that point and then go across and see if that value hits the graph anywhere. Yes, there are 2 points that have 1 as a range value. There's 1 point that has 0 as a range value. There's no parts of the graph that have -1. So that's how you trace it out to see if it actually hits the graph. Go to that point on the axis and then extend it out and see if it hits the graph anywhere. Okay? So what that means is the lower bound for my range is 0. Now, here's the question. Does it include 0 or does it not include 0? In other words, do I need a parentheses or a bracket here? Well, let's see. Is 0 a value? Now, on this side, it doesn't hit 0, but on this side, it does. So if it hits it anywhere, it includes that value. If the value is included, then I need a bracket. So the range goes from 0 to, what's the upper bound? Well, here's 2, 3, and 4. And it is including 4. All right, it is including 4. Okay? Which means I put the wrong symbol there. So it does include 4 because of the solid portion of the graph here, and then so we need to use a closed bracket, okay? And so now we have the correct domain and range for this particular function. A couple more that we need to try here, just to make sure that we have everything straight. For this particular one, again, we'll start with domain. Okay, now, for the domain, we want to see if we can find the lower bound on the x-axis, okay, lower boundary. Okay, remember, okay, this graph will continue on. It does not stop at the end of the drawing. And so what that means is there's really no lower bound for the x values. And so I know that the lower bound of my domain is negative infinity. All right, negative infinity. Okay, so no restrictions there on the lower bound of the domain. All right, so let's go to the upper bound now. Are there any restrictions on how high my inputs can go? Again, since the graph never stops, there are no restrictions, so positive infinity is the upper bound, and then now we have our complete domain. Since the domain is, the interval is from negative infinity to positive infinity, then the domain is all real numbers. Okay, all real numbers is another way to express this particular domain. All right, so many of you have probably heard that expression before. So range. Okay, so now we're looking at the y values, the outputs, possible outputs on the graph. Start with a lower bound. Is there a lower boundary? There is. It's right there, and that's at 1, 2, and 3. It does include 3, so I'm going to use an open bracket. There's 3, comma. Upper bound now on the y, there is none. The graph continues on indefinitely, and so that means that positive infinity is my upper bound. All right, so there you go. There's your range. Let's take it on now to the next one. So domain. The domain here, when we're talking about the lower bound on the x values, this is the lower bound here at 1. Again, it does include 1. And my upper bound, there is no limit, so that's positive infinity. And then there's your domain. We're talking range now. And as far as the range is concerned, the lower bound on the y-axis is 0. That's as low as it goes. Does include 0. Use your bracket. And the highest it goes on the y-axis for the outputs is positive infinity. There's no ending to how high the graph goes. And then so there is your complete range. All right? So keep these notes with you. Refer back to them as you need to when you are taking the quiz. And so that concludes the lesson for 1-4.